In this lesson, we will define standard deviation and explore which measure of variability is most appropriate. There is much detail in this lesson. Remember that you can pause the video and study any slide for as long as you want. You can also print the handout to use as notes when you are practicing. Just don't look at the answers until you have tried the exercises. We will answer two questions in this lesson. What is the standard deviation of a distribution of data? Which measure of variability is most appropriate? The last measure of variability that we will study is standard deviation. You probably recognize the term as it is the most commonly used measure of spread. It is used with the mean to give a measure of center and spread. We will start with a simple set of data. The standard deviation is a measure of average distance from the mean of the data. So the first step in finding the standard deviation is to find the mean. We now subtract the mean from each data point. This value gives not only the distance of the data point from the mean, but also a sign that indicates if it is above or below the mean. For example, data point 60 is 10 points below the mean, -10, while data point 80 is 10 points above the mean, +10. Notice that there are duplicate scores. The next slide will show a way to organize the data more efficiently, especially if there are a large number of data points. You only need one row for each different data response if you tally the number of times each response occurs and add a frequency column. This table shows that there were 2 responses of 50, each 20 points below the mean. Remember that we are interested in deviations from the mean. We don't care if it is above or below. Also, to find the standard deviation, we need to average the deviations. Averaging begins with totaling, and if we total the differences the way that they are now, the total is 0. Yet I can see that 6 of the scores deviate away from the mean 70. To deal with this issue of negative and positive differences, the third step is to square the differences so that we have all positive values. Step 4 is to total all the squared differences. The next slide shows the results of step 3 and 4 in our table. In the table, you can see that we square each difference. Since there are repeated differences for repeated data points, in the last column we multiply the squared differences by the frequency. Remember that multiplication is repeated addition. 400 plus 400 is the same as 2 times 400. In the bottom row, last column, is the total of all the squared deviations. 2 more steps and we have the standard deviation. Remember that the goal of standard deviation is to measure the average distance each data point is from the mean of the data. Step 5 divides the total squared deviations by the total number of data points minus 1, a statistical adjustment. Our final step is to take the positive square root of the quotient found. This step undoes the squaring step so that we are back to the units in which our original data was measured. In our example, the standard deviation is 16 4/100. Here is a list of the steps to find the standard deviation. Step 1, find the mean of the data. Step 2, find the difference of each data point and the mean. Step 3, square each difference. Step 4, find the total of all these squared differences. Step 5, total of squared deviations divided by the total number of data points minus 1. Step 6, take the positive square root of quotient in step 5. Here is a formula for standard deviation. If our data represents test scores, then the formula is read: the square root of the sum of the squared differences of each score and the mean of the scores, divided by the number of total scores minus 1. Here are 2 practice exercises. Find the mean and standard deviation for each set of homework scores. Also make a dot plot of each. Pause the video. Filling in the table for number 1 and following the step leads to mean equals 70, standard deviation equals 4 8/800ths. Filling in the table for number 2 and following the steps leads to a mean of 62 5/10, a standard deviation of 21 58/100ths. Have you made your dot plots? The dot plots illustrate the difference that one low data point can make to the mean and standard deviation. They do not represent the majority of the data in the second exercise. A 5-number summary would represent this data better. See the next slide. There is small variability in example 1 and no whiskers since the minimum number equals quartile 1 and the maximum number equals quartile 3. The interquartile range is 75 minus 65, which equals 10. Example 2 has a smaller interquartile range of 7 5/10. 10 is an outlier since it is below quartile 1 minus 1.5 times 7.5, or 65 minus 11.25, which equals 53.75. Here is a concept check. Without calculating the IQRs or the standard deviations, match the measures of spread to the correct grade distributions. Remember that the IQR is a measure of the spread of the middle half of the scores, and standard deviation is a measure of the average deviation from the mean. Pause the video. Here are the answers. Number 1 has the most spread. The middle half of the data stretches from about 15 to 65. In number 2, the standard deviation is larger than the IQR. It is affected by the 2 outliers, 85. Number 3 has the smallest spread. Which measure of spread is most appropriate? It depends on the question that you want to answer and the shape of your data. Range answers the question, how far apart are the highest and lowest data points? The 5-number summary uses the median to measure the center. The quartiles, along with the largest and smallest data points, help to show the spread. It gives a better representation of skewed data than mean and standard deviation. Standard deviation should always be used if the mean is given. A standard deviation of 0 indicates that all the data points are the same. The standard deviation is influenced by outliers and is the best choice for reasonably symmetric distributions. Remember, you should always graph your data first to have the best overall picture of your data. Here is the top of an end-of-grade frequency report that was printed from North Carolina Department of Instruction software. It reports the results of all the Wake County Public School System's Grade 5 Mathematics EOG test for 2008-09. Notice all the summary statistics that it gives: the standard deviation, the mode, the median. Now, notice how close the mean, median, and mode are to each other. This indicates a symmetric distribution. Finally, the 5-number summary is 330, 352, 359, 365, 379. The IQR is 365 minus 352, which equals 13. Notice the column titled Local Percentiles. We will define percentiles in the next lesson. A box and whiskers of the 5-number summary is on the next slide. Here is the box and whiskers plot. Note that 330 is an outlier, but 379 is not. Also know that the mean is lower than the median. It is slightly pulled toward the outlier. This concludes Lesson 4, Part 2. Can you answer the lesson questions now? What is the standard deviation of a distribution of data? Which measure of variability is most appropriate? You may want to use the menu on the left and review all or part of this lesson before you go on. Lesson 5 is titled Measures of Relative Standing. It will discuss the normal distribution, z-scores, and percentiles.